Hey everyone, and welcome to this explainer. Today, we are taking a really massive leap together. We're stepping away from the abstract, kind of intimidating world of computer science theory and jumping right into concrete, real-world action. We are completely unpacking Chapter 13, focusing entirely on project-based learning. I mean, if you've ever just stared at a blank screen, wondering how to actually build a working piece of software from scratch, you are absolutely in the right place. Let's figure out how to go from being a passive reader of code to an active builder of solutions together.
Okay, let's dive into this. An idea that is developed and put into action is more important than an idea that exists only as an idea. Now, this isn't just a profound philosophical hook from Gautam Buddha. It basically captures the entire core message of Chapter 13. Having a brilliant idea for an app is awesome, for sure, but it's really just the starting line. True project-based learning is all about the execution. It's organizing your time, getting your data, and actually doing the thing. A completed, functioning piece of software, even if it's super simple, is vastly more valuable than a perfect idea that just lives in your head forever.
So here is our blueprint for today. First up, ideas into action. Second, the project learning steps. Third, the power of teamwork. And finally, some real-world project examples.
Let's get right into Section 1, Ideas into Action, moving from textbook theory to a real-world mindset.
Going from textbook exercises, where you just write 10 lines of code to solve a quick math problem, to building a massive project requires a total shift in how we approach problem solving. Big projects are incredibly complex. There's massive data, multiple features, it's a lot. So how do we handle this without totally freaking out? Well, the secret is the modular approach. Think of it like building a house. You definitely don't pour concrete, frame the walls, and paint all at the exact same time, right? That would be a chaotic disaster. Instead, you divide a structured project into manageable modules. Each little module has a defined task and its own inputs. You build and test them piece by piece. And when you finally integrate them all together, bam, that's when you get your complete desired outcome.
Moving right along to Section 2, the project learning steps. This is our systematic framework for execution.
Now, what's really interesting about this slide is the structured timeline every single project has to go through. You can't just open a code editor and start typing blindly. First up is identification, spotting a real-life problem, like maybe organizing a seminar and figuring out what it needs. Second is defining a plan, getting your team together. Third, you've got to fix a time frame. Deadlines are absolutely crucial to keep things moving. Fourth is guidance and monitoring, making sure you actually stay on track. And finally, step 5 is the outcome, where your finished project gets reviewed and tweaked based on real user feedback.
Let's zoom in on that planning step for a second, because honestly, this is where a lot of ambitious projects fall apart. Defining a plan isn't just saying, hey, we're going to build this. You have to define clear roles and assign really specific activities to every single team member. And here's a pro tip straight from the chapter. Always think of the extreme situations to get a better solution. What happens if a user inputs text instead of numbers? What if the database randomly disconnects? A truly robust plan anticipates those weird edge cases right from day one.
And hey, here's a reality check on step 4. Getting stuck is completely normal. Sometimes you're going to hit a wall and think, no way, I can't figure this out. But hitting that wall is actually a built-in part of the process. When it happens, use your resources. Talk to your guide teachers, ask your peers, look up books and websites. Getting guidance and monitoring your progress isn't failing. It's literally how professional developers work every single day.
Up next is Section 3, the power of teamwork and why technical skills alone just aren't enough.
You can have the best technical blueprint ever, but it is totally useless without a cohesive crew. Real-world tasks require collective effort. The chapter uses this brilliant cricket analogy to vividly illustrate team synergy. Think about individual proficiency. A bowler bowling an absolutely perfect ball. They have incredible technical skill, right? But if the fielder drops the catch, the wicket doesn't happen. The bowler's isolated skill totally fails without the fielder's execution. It's the exact same in software. Design, coding, and testing all have to work in perfect harmony.
A successful team really boils down to these 6 non-negotiable components. You have to communicate effectively, listen to actually understand, and share your expertise. You've got to respect each other, help out when someone is stuck, and participate fully. If you're doing all 6 of these in your group meetings, your project is going to run so much smoother.
All right, finally, Section 4, real-world project examples. Let's bring this blueprint to life.
We've got the mindset, the methodology, and the teamwork rules down. Now let's apply it and prove you can actually build this stuff. First project. Imagine a new local restaurant called Stay Healthy is opening up. They need a system to generate bills and keep records. Your team's job? Develop application software to automate their entire order placing process using a kiosk right at the reception desk.
So, the crucial point is how you design the software's architecture by dividing up functionalities securely. A manager needs high-level permissions, right? They enter or change the menu, delete orders, and pull daily sales summary reports. But the customer, they just place orders via an item code and get a soft copy bill with a unique order number that resets every day. By breaking this massive software request down into these specific roles, suddenly it feels entirely manageable.
Project number 2 is a real classic, a Python Minesweeper puzzle game. The goal is to clear a grid without blowing up hidden bombs, using numbered clues. But before you even write a single line of code, the text highly recommends going and playing Minesweeper 5 times. It's absolutely vital to understand the user experience and the logic firsthand. Plus, you'll really need to think about how to handle code exceptions so the game doesn't just crash mid-click. Now, when you're diving into project-based learning, it is so incredibly easy to get overly ambitious and bite off more than you can chew. So here's the constraint. Restrict your grid size to exactly 6 by 6 with exactly 6 hidden bombs. Keeping it to this number makes the whole project manageable while still forcing you to learn all the necessary underlying logic. Get the 6 by 6 working perfectly first, and then you can scale it up.
For our third and final project, we are stepping into the world of edutainment with a game called Match the Sum. Picture this, you're in an ICT club, and you want to build software to boost the math skills of 5 to 7-year-olds. This is a fantastic example of spotting a real-world problem and designing a targeted software solution to fix it.
The core gameplay loop is fast and clever, and it revolves entirely around the number 10. A player quickly types 2 or 3 digits they currently see on the screen. If those digits add up perfectly to our target sum of 10, boom, they're successfully cleared from the board. But remember those exceptions we talked about? You have to code for what happens when the typed digits don't equal 10, and it has to happen seamlessly so the player doesn't get slowed down. To make it an actual game, we add a pressure mechanic centered around the number 15. The program displays a list of 15 cells. Random digits keep entering from the right side at equal intervals, shifting everything over to the left by 1 cell. If that board fills up completely and there's no empty cell left, it's game over. Just think about the arrays and loops you'd need to make that shifting mechanic actually work. It's an incredible programming challenge.
And there you have it. We've completely unpacked the methodology of project-based learning from Chapter 13. We've moved from textbook theory into concrete action, we've broken down the steps, we've highlighted the absolute necessity of teamwork, and we've walked through 3 awesome real-world examples. You have the blueprint, you understand the team dynamics, so the only question left is, which project will you build first? Grab your team, fire up your code editor, and let's get building. Thanks so much for joining me on this explainer, and happy coding!